Okay, so first off, let's label our side. So AC is 24. The perimeter of quadrilateral ABCD, which is a rhombus, is 52 meters. One thing about rhombi is that the sides are same. So I'm going to let this side be S, S, and S, and S. So 4S is equal to 52. S is equal to 13. So we know one of our sides is 13. Another thing about rhombus, and it's a special form of a kite, is that the diagonals intersect at a right angle. And in this case, for rhombus, it splits the diagonal into half. So this would be 12, and this would be 12. So what this gives us is a right triangle, if you take it out, 12, 13. And if you do 13 squared minus 12 squared, square root is equal to 5. So that's 5. So half of BD is equal to 5. So that means BD is equal to 10. They're asking for the area of the rhombus. If you remember, the area of a kite and rhombus special case is half D1 times D2. And so it would be half times 24 times 10. So that's 120. So our answer would be 120. Okay. So that was a relatively straightforward question. It was a question number 4, but now we're hitting a little more challenge. Question 24. There will be a lot of things to learn from this question, so I would try to attempt it, but let me read it out. In triangle ABC, point D divides line AC so that AD to DC is equal to 1 to 2. So this is if this is X, this is 2X. I'm going to give some hints when I'm reading. But EB the midpoint of BD. So that means I'm gonna let this be M. This is M. And let F be the point of intersection of line BC and line AE. Given that the area of triangle ABC is 360, right? ABC is 360. They're asking for the area of EBF. So I would try to attempt it, and then we'll come back and discuss this problem.